All right, hello everyone. So thank you for the intro so that I don't have to intro to myself because I'm not actually that good at it. So I'm going to be talking today about how to play improv with Python. I was inspired to give my talk because I went to a North Bay Python talk and it was about cocktail robotics, which was like some passion of theirs. And I thought it was really cool and I was like, could I somehow combine a hobby and Python? Right? So this is my attempt to combine a hobby with Python, and we're going to see how that goes. And since I am going to be talking about improv, we always like to start with a warm-up. So could I get one volunteer from the audience? Oh, here we go. All right, we'll start with Fanny. Come on up. All right. Don't worry, I'll call for volunteers later as well. Okay. So this is actually a game that I've actually never played before. My partner played it at an offsite last week, and it sounds fun. All right, so you are not allowed to look at my computer. Thank you. All right, so we'll just have you here. Yeah, don't look over there. Okay. All right, let's see. So this is called reverse charades. And I have, okay, good. Let's just make an iterator for that. Okay, all right. So what's going to happen is that I'm going to put up something up here that you all are going to act out. So see if you can act this out from your seat. And then she's going to be guessing what you're acting out. All right? So hopefully enough of you act this out that you'll be able to guess. Okay? All right, so no looking at the thing. All right, these are already shuffled. So let's just get the next one in here. Oh, not it. Yeah. Well, you gotta. That's true. You gotta wrap it in iter. This is also a Python talk, as you know. Okay, there we go. Okay. All right. Do you all see that? All right. Can we get some folks acting it out? There we go. Over there. Look over there. Look over there. Okay. This is amazing. Is anyone taking photos of this? Y'all are so cool. What are they doing? What are they doing? Stepping up and down. It's a sport, like a recreational sport.
Surfing, right? Surfing the internet. You surfing the internet. Skateboarding.
Yes, there we go. Woo! All right, you got it. You can go down. That was amazing. Thank you, everyone. That was beautiful. All right, so now we are all warmed up. So let me talk a little bit about my discovery of improv. So I think I first started doing improv back in around 2015. I don't only think that because I looked through my blog and I found a blog post back then. And generally I just tend to blog about everything and too many things. And so I presume that because I had a blog post in 2015, that's when I discovered it. And we did it as a club at Khan Academy. So I had a colleague who had done improv at Pixar, because of course at Pixar they do a lot of theater work and stuff like improv clubs is common there. So he brought that to Khan Academy, and so we would have this like after work improv club where we'd get together and do improv games. And I just thought it was just so cool. And that's when I learned about the concept of yes and, which is the idea that that you build on what other people say. And you'll also hear people talk about this in like kind of business and marketing classes too. But the idea is to be like collaborative with your colleagues, with your collaborators. So when they suggest something, you say, yes, and let's also do this. Yes, and let's also do this. So I really like that concept, and I just really thought improv games were really fun. So then I started getting more into it. I read a book, because I always like to read books. So if you want to read an improv book, I thought this one was pretty good. And then I started taking classes, and most of these classes are in San Francisco, so if you all are from the Bay Area, you can take these classes as well. They're all still going, which is awesome. So I started off at Endgames Improv, which is on Mission Street, and basically went and took like their whole series of classes. I think I took like the first 4 classes, and I would always stop when the classes got too advanced because I didn't want to do like actual like true like theater improv scenes. I just wanted to do like fun casual games. So basically my goal was to take all the intro level improv classes I could possibly take, right? So I started Endgames, then I went to Leela SF and I did all of their intro level classes. Then I went to Studio ACT, that's in downtown San Francisco. They also have all these other really cool classes. I did singing class there. I'm still a horrible singer, but it's still really fun. I did mass class. Mass class is really cool. It's based off this Italian theater form. It's where Punch and Judy came from, and you can actually like make your own mask too, and it's just really, really cool. And that was taught by an actual clown. So my teacher was a professional clown. She was kind of like a political clown, because this is San Francisco, right? So you can like rent a political clown, which is great. Like if I could like one day be a political clown, like that sounds like a pretty good life. So Studio HD next, and then I moved to Berkeley and continued the improv there. I went to Berkeley Rep and did improv there. So all over the Bay Area, you can find improv classes. I do recommend it if you're improv curious. So once I learn something, I always like to spread it to others. I like to share it, right? So my next step was, after I've done like, been a little improv addict and done all these, was to spread improv to other people. So I started running an improv club out of my house. So I invited people over every Friday night. We would play improv games. We even eventually rented a venue in Temescal, Oakland. This is us at the venue performing for about 5 people, including someone's mom. And I don't think she liked my improv jokes, but of course I'm a mom now, so I still like my jokes. So I ran our improv club and did a little performance too. I also tried to bring improv to workplaces. So when I was at a startup, I brought this shake-off, which was a 15-minute improv. So basically, I think it was like at 2:15 every day. We would just yell, "Shake off," and then we would all go and gather in a circle. This is a startup, so there's only like 10 of us, and then we'd play all these games in a circle. Here, this photo is when we were working out of WeWork. And this was WeWork Tenderloin. So we would be this is actually in the elevator well. So we'd be playing improv games in the elevator well. And people would be like trying to walk by us. I think everyone probably didn't like us, but we had a lot of fun, and it was a cool way to bond with my colleagues in a different way. And then of course laser cutting, right? Here we go. I brought it. So like most people, I started a laser cutting habit. This was back when Tech Shop was going, right? Tech Shop in downtown, yeah. So I got into laser cutting and was like, okay, this is what I need for my club. Because what I have here is like just hundreds of improv games, right? So every night when we had the improv club, I would say, okay, this is our set list for tonight, and then just hang it up. So that is my patented invention there for improv. And then finally, I am a documentation nerd, so I had to document improv. So if you are looking for a GitHub repo that is full of, I need to figure out the Wi-Fi. What's the Wi-Fi? All right, I'll connect to myself. Well, my personal hotspot is one lonely number. Okay, so here we go. All right, so I made a GitHub repo. And this, of course, is why I probably have way too many repos, 300 repos to be precise. And in this repo, I have documented like hundreds of games. I've got collections. I've got set lists. I even got a collection of games for video conferencing, because, of course, many of us are remote and on Zoom now, right? So these are all ones that should actually work on a Zoom call. So those are all documented here. So every time I would learn a new game, I would add it. Right? So there's quite a few there. All right. So finally, let's actually talk about making some improv games happen. So there's a lot of different kinds of improv games. Some of them are purely verbal. Those are the kinds of ones that are really good for video conferencing, right? Because you just need words, right? So there's storytelling games, there's word games, there's pun games, all sorts of generative verbal games. Then there's a lot of physical games, right? And those ones you really need like a space to do it, so you can like work around each other and create things in the space. And then there's things revolving around scenes. So like trying to build up a character, build a scene, experiment with status, like social status. Like there's one where you'll walk around and like pretend that some person's really important, but they have to realize they're really important. There's stuff like that. And then musical improv. So if you like singing, lots of kinds of games there. So let's try another game. So can I get another volunteer, or even a couple volunteers? Blake, thank you. And then, what's your name? Yeah, come on up. All right, that should be a good number. Okay, so this is a verbal game, and this game actually came from Pixar. So, Pixar makes movies, so this is called the Pixar Story spine. And the idea is that if you follow this story spine, you should be able to come up with a Pixar movie, or, any sort of movie. So what we're going to do, okay, so we have Blake and Jesse and Pamela. So we're going to go through this spine, and we're just going to go through it in turn until our story is done. Ready? All right, and let's go over here so we're closer to the microphone since we're being recorded. Okay. All right. Who wants to start?
Sure.
Okay, go.
Once there was a loaf of bread.
And every day, the bread was hoping.
Until one day, the bread realized that what it really wanted to be in life was a frittata.
And because of that, it went into the oven.
And because of that, it had an amazing idea.
And because of that, in the oven, it went and it met a beautiful egg lady.
Until finally, it became French toast.
And so, the lesson is...
The moral of the story is the toastest is the mostest. All right, there we go. Now we got it. All right, thank you so much, volunteers. So we're actually going to play that with improv in Python very soon. So that gives you an idea of a verbal game. Here's the thing, it's you don't come up with a Pixar movie every time. The point is just to exercise, your, the improv part of your brain to be able to just, be able to respond off the cuff, right? And, sometimes you come up with Pixar movies, maybe not that time. So, I don't know, we can propose it to them. They're just down the street. All right, so now let's play improv with Python. This is a Python conference. This is what we're waiting for. All right, so the question is, can we play improv with a computer, right? Imagine I'd gotten no volunteers and I needed a computer to help, right? Could we play improv with it? So we need the computer to generate a creative, human-like response. Now, years ago, I dreamed about doing this using hidden Markov models. If you've never made a hidden Markov model, it's basically looking at a bunch of text and saying oh, this word, is followed by this word, a certain probability of the time, and you come up with this, fairly simple model that can still come up with cool output. But then I also thought oh, well, you could do a custom training of ML model. However, I'm not an ML engineer, so I never went down that path. Now, of course, we do have language models, right? We've got large language models and we've got small language models. So when language models first came out, I was oh, wow, now I know who I can play improv with, right? But I never had the chance to try it until this conference. So I was really excited to finally get a chance to try it out. Because it's literally what they're good for, right? Everybody complains about language models making stuff up. We want them to make stuff up here, right? We're going to take advantage of it this time and see how that goes. So there's a lot of language models out there. There's a few that we're going to try today. So we've got OpenAI has a GPT-4o mini. That one's interesting because it can look at images as well. That way we can have some props. Then there's also ones, Meta has the Lama 3.18b, which is actually a really nice small model. And then Microsoft also has the Phi 3 3.8b, which is also a small model. So some of these I can actually use on my machine. Other of them I have to use on, on a host, since they're way too big for my little Mac. So let's talk about Olama. Is anyone using Olama already? A couple people? Okay, so Olama is amazing. Firstly, because it puts an adorable llama in your taskbar up there, which I just trying to collect all the animals, because now I've got elephant for Postgres, the llama for Olama, and the whale for Docker, right? So it is a tool that can run LLMs easily on your computer, and it works on Macs, which is awesome, right? And it actually, even if you don't have a very powerful computer, you can use Olama. You can even use it inside a GitHub code space, and that's what I use when I'm teaching workshops, because then you don't have to have any particular computer set up. So let's see how Olama works here. I've already got it running here. I've already got it downloaded. We can see, let me make this even bigger. Olama list. Okay, so these are the ones I have downloaded right now. So if I do Olama run Phi 3.5 latest, that's already downloaded. So it's just loading it up here, and so I'll be able to do a little chat with it. And then let me also, because this is fun, I'm going to show you, I was at the PyTorch, was anybody here at PyTorch? PyTorch? No? Okay, so I was at the PyTorch conference this week, and somebody taught me about ASI Top, which is a cool utility that shows you your GPU usage. So we're going to do, we have to do sudo ASI Top. You can brew install this if you want to install that. Okay, so now I've got Lama running here. We'll just say hi. Okay, thank you. All right, and now you can see, okay, see my GPU usage? Watch that, okay? See the GPU usage here? I'm gonna be like, hey, come up with first line for an improv scene. All right, look at my GPU usage, bam! Okay, longer line. Just wanna show yeah, there we go. So it is actually, Lama uses all these tricks to be able to run efficiently on your computer depending on your computer setup. So in this case, it is actually able to use the max GPU, even though it's not like a standard like NVIDIA CUDA thing. It actually uses something called the Metal programming system, but it's able to use that. It uses any trick it can in the book. All right, so that's the terminal for interacting with Lama. Now we can also interact with Lama over HTTP. All right, so here, I've got a post to the Lama endpoint, right? So I say, here's the model. This time it's Lama 3.1. And I have this, same thing is I'm using a chat conversation model. So saying, here's your system prompt. And here's the first thing we want is a random first line for a scene. Okay, so I'll send this request here. We can go out of that. Okay. And this is using the VS Code REST client, which is a really cool way that you can have HTTP files and you can just issue your HTTP request. It's very fun. So here we got back a response, and it has a first line that it recommends here. All right, so that is the HTTP endpoint. We can also use Lama from the Lama package or from the OpenAI package. So I usually use it from the OpenAI package because I'm more used to that package. So here, this is how we'd use it with the OpenAI package. So we create an OpenAI client. We point it at the local Lama server at the OpenAI compatible endpoint. So Lama actually exposes two different endpoints, one that's their own format and then one that's OpenAI compatible. So we're going to point it at the OpenAI compatible one, which is /v1. And then we don't need a key, but we still have to say we need a key. So we pass in some nonsense value here. And then the model name, and then we send off the request. All right, so this is going off to that local server and making the request again. This time we're doing it to 3.5. So one thing about these local models is, at least on my computer, they're slower because my computer is not very powerful. So if I was making a request to a model on a server, it would actually be faster just because of the server's faster. But I just think it's cool that you can actually run these things. You discover that your houseplants have formed secret meetings and decided to demand their own rights as sentient beings. That's a pretty good prompt. Okay. All right, so that's using Lama. So we can use that to access all the small models. The next thing we can use is GitHub Models. This is something where you can use large models for free, and all you need is your GitHub token. It is waitlist only right now, so you have to sign up. We're begging them to make it open for everyone. But I think basically everybody who's signed up for the waitlist is on it right now. So similarly, we can call those using a very similar looking HTTP request. So this time we're passing in a GitHub token, but we're doing it all using the same OpenAI protocol. So basically what happened is that OpenAI was the first one to come out with large language models and the first one who had an API and an SDK. So everybody copied them. So even when we're using non-OpenAI models, they mostly all offer OpenAI compatible endpoints, which means that we can, interface with them the same way. We can use the OpenAI SDK with all of them. So that's what I tend to use. There's other things you could use like LangChain or Light LLM. But this is what I prefer to do. Okay, so then we got a response from there. All right, and then similarly, we can use the GitHub models via the OpenAI client. We just have to change the base URL and pass in the GitHub token as the API key. The funny thing is that I'm not using OpenAI.com for anything. Oh, and it says it must be set by passing API. Okay, that means my GitHub token expired, so we just won't use, wait, did I do it from there? Export, oh, I must have done a new terminal. Let's see if I do it over here. Python, OpenAI. That's the thing with setting things in your terminal, is that they could go away. There we go. This terminal has my GitHub token set. All right, cool. Okay, so those are the two models that we can use, right? And we're going to do it using the OpenAI SDK because it's a common interface. So that game that we just did, Story Spine, let's see how we would actually do that with Improv, all right? Okay, so here is our code. So what we have at the top is just a switch for whether we want to use Lama or GitHub. And then we have our players, right? So instead of like Blake and Jesse, we're going to have Lama and 5.3.5 as our players. Here's our story spine in a list. And then, here in the system prompt, this is how we give the overall instructions to a language model. We say, okay, your goal is to collaboratively write a story, only complete the sentence when you've been given the start. And so we're going to go through each one. And also, I have the user as a possible player here too, right? So I'm saying, okay, we've got the user and two different models. And when we're sending it to the user, we're just doing input, console.input. When we're sending it to the LLM, we're actually sending a message that says, hey, complete the sentence that starts with, once upon a time. And include the full sentence in the response, only respond with a single sentence. We have to give it really explicit rules. Language models don't like to follow the rules, so we have to be really explicit, right? Humans are generally a little bit better. Y'all were great. All right, so let's try running this. Okay. All right, so so this one started off with, once there was an old sailor, every day, strange smoke signals. Okay, now it's my turn. All right, until one day, the smoke was gooey. I'm like really lazy when I play with large language models because I just let them, fill it in, right? So we've got like an attic, we've got smoke signals. I turned that smoke gooey. So Phi likes to be like really verbose. Okay, and here's the thing, is that it's really hard to get these language models to just respond with a single sentence. They always want to keep going. They want to like keep adding, keep on filling in the story. And that's one of the troubles I've had with, with these models. Because of the disconcerting gooey smoke signal, the old sailor held an emergency gathering. They dove into the ocean and found mermaids. I don't know. All right, and then let's see what will happen. I'd just like to throw them weird things and see how they respond. Okay, really, really verbose. Unexpected twists had connected realms. Okay, the moral of the story is mermaids are cool. Okay, all right, here we go. So what we've seen is that, we were able to play with those large language models, or small language models, but they weren't very good at, doing like a single sentence, right? Like they like to, kind of add on to it. And that's one of the difficulties that you'll find working with language models, because I also work with language models in like professional context and use them for real things. And the same issues that I ran into when doing improv are the same issues I run into when I'm using them for RAG, retrieval augmented generation, which is an approach that I use professionally with LLMs. All right, so we were able to do it, but as you see, there's they're not quite as good at doing roles. All right, so the next challenge is sentence at a time story. So this one's really similar, but the difference here is that, with that story spine, we had a clear end, so we knew when to end. But if there's no clear end and we're telling the language models like, hey, you need to come up with the end, will they end it? Will they ever end it? Will they end it like at the good time? So let's see. So here I'm doing the players. All right, let me do the players as just the models because I'm like lazy, right? So it says, if it feels like the story is complete, you can end the game by typing the end. And then I have this really great line of code here, which just tries to see if the last message ended in the end, right? Very elegant. All right, so let's try this. Python sentence story.py. Okay. An old spacecraft. And, okay, so we've got an old spacecraft parked outside somewhere. And then, okay, this is what keeps happening. Phi keeps ending the story after 2 sentences. Phi's always like, oh, it's my turn, I'm gonna end the story. So, yeah, so that's interesting, is that, I think with humans, we'd probably like go a little bit longer than that. But here we go. An extraterrestrial being named Zorx launched comfortably on a shifting methane chair, sipping synthetic coffee. It's sourced from comet ice melt as part of the menu diction by cosmic culinary experts. The end. Okay, thank you. So that's interesting, right? In this case, it actually ended too quickly. I had other issues using other models where it just never, ever ended. So, your mileage may vary there. Yeah, so you can end the story, but when are you going to know when it ends, right? Like you have to tell the language model like, hey, use this token or use this phrase, and then hope that it actually is going to obey to it. All right, and now word at a time story, and this is where we're going to look at the fact that language models really can't count, right? You tell them to give one word, right? Okay, Blake, can you come up so we can do word at a time? All right. I'm using Blake because we once had a dance-off while I was pregnant, and I still won it. Okay, all right. So our game is tweet generator. We're trying to write a tweet together. Okay, do you know what a tweet is?
Yes.
Okay, I don't know if you're in tweet. Okay, all right, so it's going to be one word at a time, and then when you think the tweet is over, just hashtag it, and that'll be the end of the tweet, okay?
Okay.
Okay, all right. Whenever...
Wait, what is the...
One word at a time.
Oh.
It's just us.
Whenever. Oh, yeah, you said whenever.
Whenever.
I.
C.
A.
PyBay.
Patron.
I.
Give them. Give.
Them. Hug.
Hashtag.
PyBay love.
PyBay love.
All right. All right. Thank you, Blake. Okay. So for this one, the big challenge was getting to do one word at a time. And so here I'm using something called few shot examples. So that's where you actually show the LLM like, hey, if somebody had already gone through this, this is what it looks like, right? So I'm saying like, okay, the quick brown fox jumps over the lazy dog, hashtag animals are weird, right? So the idea is that by giving few shot examples, you can like really give it an idea of what it should look like. And that's a good technique to use, especially with these smaller language models, right? All right, so let's say word at a time, okay? All right, so I'm going to start off. We'll do whenever, and then it's going to go to Lama and Phi. Okay, whenever I, that's similar to ours. Okay, whenever I notice, and see how Phi keeps putting quotation marks after the words and like a new line. It actually did a new line if you see how much new space was there. So Phi, like it's really hard to get it to stick with one word at a time. And one thing you could try is that there's this max tokens parameter. So you can tell an LLM how many tokens to give back. But the thing is that tokens don't map to words. So sometimes a word is a single token, but other times a word could take like 3 tokens. So if I say max tokens equals 1, sometimes I'll get back a single letter because that particular word is actually split up into 3 tokens. And this varies based on the language too. Like English tends to have the 1 token, 1 word ratio, but as soon as you go into non-English languages, because of course LLMs are skewed towards English, then there's, all of their words take up more than 1 token. Notice PyBay has a conference. Okay, if I do a sentence, usually that gets it to hashtag it. Because look at now, Phi is doing markdown. Phi, why? Why are you doing that? And then Llama 3.1 decides to say lot of, which is cool stuff. All right, I'm gonna end it there. Okay, so this was the final tweet. Whenever I notice PyBay has a conference, lots of insight to share. Hashtag cool stuff. with a mix of markdown and random quotation marks, right? So it actually is really tricky to get it to do one word at a time. Now, of course, one thing I could do is just like do data processing and just split the response that comes back and just say like, okay, well, we're only going to take the first thing that actually looks like a word, so we just split on a word boundary. Once again, regex. It's amazing how often I mix regex with language models. The other thing we could do is we could try fine-tuning. Now, that feels like a waste of energy to fine-tune for improv, so I didn't do it. I was tempted. But the idea of fine-tuning is that you're just tweaking the outer layer of weights on a model to subtly skew it to match your domain, right? So this actually is a common thing people will do, you know, with the professional use of language models to try and get it to have better responses for their particular domain. And it probably would work in this case if it's been trained with lots of word-at-a-time examples, but it takes a lot of time and energy to do fine-tuning. I can't physically do it on my Mac. It doesn't have the power available to do it. But I am trying to make friends with lots of people who have NVIDIA machines so that I can fine-tune on the machines. So we did Fusion Learning. That helped a bit. We could try post-processing, with regex. We could also try fine-tuning, and that could help with this sort of thing. All right, props. Oh, yeah, so here's the props. All right. Wait, so how much time do we have? Okay, plenty of time. All right, can I get a volunteer? Anyone? All right, come on up. These are a selection of toys from my children that I stole from their toy box. Okay. Okay, cool. All right. What you're going to do, all right, let me grab, all right, you're going to pretend you've never seen this before. Have you ever seen this before, sir?
No. What is that?
Yeah, exactly. All right. Okay, so we are the yes and product factory. So the first thing we do is just describe the object, and then we're going to turn it into a product by saying yes and it blah, 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 blah. We're going to make it an extraordinary product together. And then we'll just end when it feels like it's amazing. Maybe give it a name. Okay. This is a amazing construction device.
Yes, and it transmogrifies the peanuts.
Yes, and the peanuts turn into psychics that can predict the futures of all nuts.
Yes, and they communicate with me when I'm sleeping.
Yes, and according to my dreams, we should all start eating much more Turkish delight and less peanut butter.
Yes, and the peanut butter should be spread all over the walls.
Yes, and then you just put yourself on the wall and you just go like,
I don't know where to go for that.
And the name of the product is?
The peanut butter spreader.
Woo! Thank you. All right, so there we used a prop. So the question is, how do we use a prop with a language model? So what we're going to do is actually use a multimodal model. So this is a model that can both reason over text and images. So there is a, let's see, what we're going to use. So actually, I hard-coded the model names here, right? So with Lama, we can use Lava. That is an open, local model that we can use that has vision in it. So it's like Llama, but it has a V, so it's vision. And then with GitHub, we can use GPT-4o Mini. So basically what we do is that we say, we take an image. So I actually have images of all of these pictures, right? So there's like the one we just did, right? The sonic screwdriver. And I will, pass that to, I load it in, and then I base 64 encode it, right? And then pass that to the model and say, okay, here's the image, and all it sees is the image. It actually doesn't see the file name at all. It only sees the image, and you need to come up with a prompt for it. So you can see the prompt is, pretend you've never ever seen this object before and describe it as if it's a new invention from a toy company. Use only a single sentence to describe it. So we're going to use that multimodal model for the first step, and then going on from that, then it's just like what we had before, where it was like, okay, what are we building? Until we get to the end, a certain number of rounds, we say, okay, what's the name of the product, right? So let's see how this one goes. We can try it. Okay, should we try it with the same one? We can try it with the screwdriver. So toy. All right, so we'll do the toy sonic screwdriver. That ping. Okay. All right, and then here we go. Okay, using the Lama hosted model, so that's lava. And the first step is describing the object. So let's see what description we get for this. An inventive, playful, handheld device. Oh, yes, and it is GUI. I'm sorry, it's just always going to be GUI. It resembles a futuristic communication tool, combining the best of modern technology with an imaginative design. I had to really get the LLMs not to actually say what they were, because a lot of times the models actually know, like, this is a sonic screwdriver from Doctor Who, right? So the unique viscosity, look how viscous it is. Wait, what is this? The balls I started telling the story about had to disappear? I don't know. Sometimes it like will just go off into, all right. And then 5.3 says, oh, 5.3 wants to start like naming it right now. Yes, and it can be eaten with a straw. So 5.3 always wants to name it really early, even before I've asked for a name, because the actual name is, of course, the slug novium. Even though 5.3 tried to call it the neuroguzzler way back. But that's pretty fun, right? So you can see how we can combine models that have different capabilities so that we can use vision, but then also use the language capabilities as well. Oh man, they always crack me up. Okay. All right, so this is the final game, which is 3 things. Okay, can I get one more volunteer? All right, come on up. If you want to volunteer, you can come up too. We can have multiple people. Yeah. Usually with improv, you actually have like 5, 6 people at least. All right. So here, okay, the rules of 3 things. Yeah. So there are rules linked for all of these. So with this game, we're just gonna come up with the categories. So I'll say like 3 things that blah, and then you're gonna just say 3 things that, and then you'll just say 3 things, right? So basically like 3 things that you bring to Mars, and you'd be like astronaut, spacesuit, food. Right? It helps to go like this. And then you'll do it, and then I'll do it, and so we'll just do like 2 rounds of it, okay? All right. Do any of you want to come up with the category for us? 3 things that...
You bring on a picnic?
All right. Okay. So you did 3 things you bring on a picnic. Okay. Ants, blanket, and food for the ants.
My children, a picnic basket, and bear repellent.
Sandwich, basket, mosquito spray.
Okay, and a flowery dress, and a kite, and a frisbee.
Scissors to cut the string on your kite, and a dog to chase after the frisbee, and a bear to chase after the dog.
And dog repellent, because I'm allergic, and some more sandwiches, and some clothes to hang.
All right, 3 things. Thank you. Okay, so that was 3 things. Thank you so much, Zakaria and Adam. All right, so you can go down now. We'll see how to code it. Thank you. Okay, so how do we get a language model to answer with 3 things? So first we'll start off with, the way we've been doing it before is just using prompts. So we're saying like, okay, you have to come up with 3 things, right? And we'll start off with the category, and then we say, okay, suggest the category, and then from then on we just say like, okay, suggest 3 things for the category. Actually, I had to be really verbose in this prompt. 3 more things from the category that are completely different from any previous suggestions, because for some reason Lama just wanted to keep suggesting the same 3 things. I was like, no, different. Don't just keep saying the same 3 things. All right, so let's try this simple version first. Okay. 3 things that fit in your nose. Actually, no, I did this other one last night. 3 things that you do on a first date. This cracks me up. I was having a good time working on this yesterday. Okay. So Lama's like, recreate a dramatic memory, conduct an impromptu art gallery, showcase the ridiculous sculptures you've made, develop a new time travel recipe for visiting Paris under Napoleon's rule by making tiny sandwiches to send via snail mail. Okay, and then Phi 3 decides to suggest 4 things because it needs to one-up Llama. Here are 3, okay, once again, the models cannot count. Here are 3 distinct activities followed by 4. The final one is a dorm escape room. Okay, become amateur stand-up comedians. Okay, and then, yeah, cafe, a hot cocoa, a hug. Okay, all right. So that's how it's supposed to be done. Let's see if they'll like now be a little better at sticking to it. So this goes through 3 rounds. Because you see how they're like really verbose and also not even sticking to 3 things. All right, so once again, Llama really wants you to time travel. See how it says completely different activities and then immediately says time traveling? Like, okay, all right. Achievers of parallel universes creating mini championship. And then Phi, of course, has 4 suggestions. Okay, all right, so we're gonna put those out of their misery. All right, so what I wanna show you is using function calling. So this is a technique where we actually specify a schema for a function that we want the language model to call. So we're telling it, hey, you need to call a function called 3 things, and you're gonna pass it an array, and that array has strings in it, and it should be 3 items exactly, right? So min items 3, max items 3. So we're using JSON schema, actually. We are describing the function and saying, hey, this is the function we want you to call, and it should only be given an array of 3 strings. And so this is a technique we can use to try and get more structured outputs out of LLMs. There's other techniques as well, but this is one that is supported with both OpenAI models and Ollama. So that's why it's the approach that I like to use when I'm trying to get structured outputs. Right? So what we do is and I am also using few-shot examples. The few-shot examples are different this time because it's actually a function call we're trying to get them to respond with, right? So here, this is an example of how we want it to respond. Like, okay, here's an example list that you're gonna pass into this function. So that's what we're gonna get back is an actual description of a function call. So the idea is to actually get a list of 3 things, right? Okay, all right, so we have some examples, okay. And so what we do, and the way we pass it in is we just say tools equals tools, and that passes in that function definition, so it knows to use that and do a function calling request. And then we parse it back out of the response. All right, so let's try this thing. 3 things, tools, okay. All right, let's see, let's try the first date again. And it's gonna be really different because this time we're getting back a list and then I'm just joining it with a comma and outputting it. All right, dive to 0 miles per hour, visit a sensory deprivation test, host your own reality TV reboot with you and the other person. Okay, that was 3 things. It was 3 things. Okay, oh yeah, cafe, hot cocoa, hug. Okay, all right. And then it's going to Llama again. Extreme ironing. Geocaching and astrology. Thank you, Lama. And you'll notice I don't have Phi in here. That's because Phi 3 doesn't support function calling with Ollama yet. I've requested it, so hopefully it'll happen. But there's only like 3 different models that support function calling with Ollama, and this is the only one that fits on my machine. So this is the only one I could show you with Ollama is Llama 3.18b, but it does work pretty well. So that's cool. So that's a way that we can get much more structured output and actually get it to count. Because apparently it can't really count, but it does know how to adhere to a JSON schema. Who knew? All right, so yeah, so when you're trying to get this sort of structured output, your options are to use function calling, use few-shot examples to improve that response. There's a whole LangChain blog post where they researched it and tried different few-shot techniques to improve tool calling. There's also other packages you can use for structured outputs and also new ways of doing it from APIs. So lots of different options. All right, so getting to the end here. So lessons learned while trying to mix improv with Python. Generally, larger models are better at following the rules. I mostly showed you the local models today. Had I switched over to the GitHub models, you would have seen generally better rule adherence just because they're much, much larger. Right? If I'm using larger models, they're going to be better at following the rules. But I find it interesting to see how the small models do. Because maybe the future is small models, right? Like we're starting to get like actual like small models like on our computers, our machines, like on our phones, right? So I think it's useful to understand what they can do and not do. Generally doing anything with language models will teach you a lot about them. So if you have some particular idea in mind that you want to try out, even if it is ridiculous, like playing improv with Python, you know, just try it out because you'll learn something, right? Improv with computers is fun, but improv with humans is more fun. So thank you to all the volunteers for coming up. And of course, everybody who was skating at the beginning. It was amazing. And that's it. Okay, that is what I have for you today. Thank you, everyone. You can grab the slides and all the code if you would like it. All right?
We have some questions.
Adam. Oh, yeah, you get a mic, sorry.
Oh, sorry, thank you. When humans play improv, we kind of know the context, like this should be entertaining or whatever. Have you
Yeah.
tried like including in the prompt things like be silly or be ridiculous or be surreal or?
Yeah, I did that
Anything like
in, let me see where I had to do that. So in three things actually the prompt says, the things don't have to be real, just suggest whatever comes to mind, right? Yeah, so I did that in some places. And so that can definitely affect it, because I was finding like that the responses were like too serious. So yeah, I think that definitely can help, along with few shot examples to give ideas, or even you can just do examples here, right? You can be like, for example, alien repellent, right? So you can do like actual few shot examples, or you can give examples in the system prompt. But yeah, it's a good idea, and you should fork and try more prompts and see how it works. It's interesting because I've done lots of evaluations for RAG applications with different prompts, and a lot of people try to be like, oh, you're like a customer service support person, you're very, very helpful. What I found was that LLMs are always helpful. So if I just stripped out all of the fluff in the system prompt and only retained what I needed in sort of like kind of syntax, right? Like you need to cite your sources in this manner, I got the same results. So I think it's good to experiment, but you have to, like, what I realized is that LLMs by default are kind of designed to be helpful. And so if that's your use case, you're trying to make a language model be helpful and give helpful responses, it's already very good at that. But what we need is like, yeah, if we do want it to be sillier and to be like, not as serious, right? We can do that. We can also change the temperature. So, I didn't point out the temperature here. So actually here I was using 0.3, which is usually a good thing with function calling to have it not be too creative. But with other ones, I probably did, let's see, what temperature did I do to this one? 0.7, right? So you can do the temperature from between like 0, 1, even 0 to 2. If you do 2, it'll be absolute nonsense though. So I never go to 2. I never even go past 0.7. But that would be another way of getting more, unexpected results, right? Because basically with the temperature, you imagine like every time a language model is picking a next word, because a language model is just a next word predictor. So every time it's picking a next word, every word has a probability. And if you increase the temperature, then it'll consider a wider range of probabilities, right? So it just increases the possible tokens it might pick as that next token. Any questions? Microphone. Run.
I like your presentation to this room full of Python people, and I was wondering, how does your talk go over with people in the real improv community who say don't know Python?
Well, I'm not in it anymore. So I unfortunately haven't even gotten to do improv in like 5 years because I have a 2-year-old and a 5-year-old. I mean, I improv with them every day. I also that was the other reason I'm talking. I was like, what is something that my kids would actually like? I don't know. Around here, there's a large number of programmers in that community too, but not for like the professional performers. As in, like, would they think it's a good thing to have computers play improv games?
Yeah, 2 weeks ago I went to see Ben Schwartz in town, and all long-form improv. And I couldn't help but thinking about that through your talk, how that would go over. It would be a riot, in my opinion.
Yeah, well, if the improv community invites me to, give a talk,
Okay.
I'll let you know how it goes. Yeah, I hope to get back into improv, because doing this talk and like looking through my photos and everything, I was like, oh, I miss improv.
We can do one more question. No, I have one quick question. I'll shout. My microphones are way back there. Can you say to the large language model, be very, encourage brevity in responses, like with sentences
Yeah.
no longer than, 8 words or 10 words or something like that. Because even
I try. Let me tell you, like these language models, it's just hard to rein them in. No, you can certainly try. And, that's the sort of thing like, you can make these changes. And so when I'm doing this, like for actual applications, I run. It worked. It worked. So if you are gonna do prompt engineering with a natural language model deployment, the good thing to do is like run an evaluation across like a bunch of different pairs. Like I actually was running evaluations for RAG against both Llama 3.1 and Phi 3 this week to see how well they could come up with like citations. And so there I run it against like 200 examples, right? Because here's the thing is like I can make a small tweak, and for that first sentence worked great, right? She lived. And then, of course, now they're both saying your turn, because Lama started it. But then look, like now Phi 3 has gotten longer, right? So if you are going to do a tweak to a prompt, and if this is something you're like using professionally, then you want to actually evaluate like 200 different scenarios and see like, did it really move the needle? Because sometimes it'll move the needle for that one scenario, and you're like, oh my God, it worked. And then you try another one, and you're like, oh, it didn't work. Right? So this is what I find is that like it's helpful to like do experiments and try a couple examples, but then you really want to have a pipeline in place in order to do a lot of evaluations on a bunch of data.